Hi everyone. Light passes through different objects. When it is passing through different objects, what changes it makes? Light may change its velocity and change its path while moving. It is based on the surface structure also. If the surface is plane, then light refracts angles, different things we know. If the surface is curved, what happens? You might have played with a magnifier. Have you ever played with a magnifier? What happens if you expose that to the sun? You might have burnt papers with the magnifier. How is it possible? What is happening there? Magnifier is nothing but a convex lens. It is changing the path of the light, direction of the light, and it is converging all the light rays at a particular point. Now, so let us imagine this is sun and you are using a magnifying lens here. The light rays which are coming from the sun, the light rays are coming from infinite distance and they are converged at a particular point, and here the image of sun is formed. This is image of sun. All the light rays are concentrated or converged at a particular point. The strength of this converging, the capacity of strength, capacity of converging the light rays here is called, at what length it is converging, this length of convergent is known as focal length. Now, let us see how the sun rays are converged with the help of a convex lens. We have another type of lens also, double concave lens. What happens if the light exposed on the double convex lens? So, here to understand this phenomena, first we should know what is happening, how the light rays refract. For that case, let us take a simple structure. A curved surface is there. At certain point, there is a center of curvature, and a light ray falls over it. Let us assume a light ray is coming. In which direction after refraction the light ray should pass? For that, to know that, from that point we have to draw a normal. This is a normal. Here the light ray is coming from air and it is moving into glass, denser medium. Air is a rarer medium, whereas glass is a denser medium. When the light is passing from rarer medium into denser medium, what should happen? Light rays should move towards the normal. That is to say, clearly to say, here it is air and it is glass, and if you draw a normal, if the incident angle is like this is normal and this is incident angle, and it should bend towards normal. Angle I is always greater than the angle R when it is moving from rarer medium into the denser medium. So, here it is changing the path. In this way, it is changing the path and converging at a particular point. The strength of converging of this convex lens is called, at what distance it is converging is called focal length. What happens if it is with the another type of lens. We have another type of lens, biconvex lens. Let us assume that the same light is falling over it, the light which is coming from the sun. What happens? The sun rays travel from infinite distance, and consider all the rays are parallel to each other. By looking at this principle, here light ray is entering into the curved surface. So, here what happens, after falling over it, the light rays change their direction. With the same principle we can explain it, diverged. But if you extend all this at a particular point, they tend to meet. The capacity of diverging, in what way it is diverging, what is the strength of the diverging, this distance is known as focal length. Usually this focal length is denoted by f. Focal length is denoted by f. The focal length is nothing but how strongly the light rays are converged or the light rays are diverged by a lens, we can call them as focal length. Here, whenever we consider a lens, there are two refracting surfaces, surface 1 and surface 2, usually on which the light ray incidents, we can call them as a surface 1. In which way the light is emerging, that ray is known as surface 2. Based on this, we can find the focal length, focus point where the light is focused, that is known as focus point. The distance between the focus point to the lens is known as focal length. So, usually that can be shown in the diagrammatic way, in this way. To understand the nature of images, we have to learn few terms. One is lens. Usually either we can use convex lens or we can use concave lens. Every lens has center of curvature. Here for this curve also we have one center, for this curve also we have one center, two curves are there. So, if you consider this is a surface 1, this is center of curvature 1 and this surface has 2, this is C2, curvature of surface 2 and this is curvature of surface 1. And a line joining these two centers along the center, optic center of the lens is known as principal axis. This is known as principal axis. When the light is coming from infinite distance from one side, all these light rays, let us assume that they are parallel and coming from infinite distance, they all converge at a particular point. After passing through this, they may converge at a particular point. This point is known as focus. The distance between these two is known as focal length. Similarly, if the light comes from this direction, if the light falls on the lens in this direction, what happens? Its focus, same type, the light rays may converge at a particular point. This is also another focus. This is from surface 2, therefore, we call this is as F2. This focus is from surface 1, therefore, we call it is as focus 1. So, these are the fundamental terms what we have to learn when the light is converging or diverging. Principal axis, center of curvature and focus where the light is converging. Similarly, the same type of thing can be seen for concave lens also. After the falling light rays on the concave lens, what do? Just they diverge in different direction. They change their path and move, but if you extend back, they are tend to join at a fixed point. When we see from this side, you feel that the light ray is coming from this fixed point. Therefore, this point can be considered as focus. And for this curve, there will be, this is the surface 1. For this curve, we have center of curvature this side only. Therefore, surface 1 C1, surface 1 F1. Similarly, for this, if you consider, you will have F2 and this is surface 2. Therefore, center of curvature 2. In general, while drawing the diagram, for convex lens, we use this symbol. This represents convex lens. This is convex lens. For concave lens, we use this symbol. So, here it is thick, whereas it is thin. Therefore, usually for every time without for not need not to draw like this, but if you indicate in this way, it shows convex lens and it shows concave lens. So, in this way we can find out the focal length of the lenses. So, what does the focal length says? Focal length says that in what way, at what point it is converging. What happens if you change its radius of curvature? What happens if you change its radius of curvature? When you are changing the radius of curvature, certainly the focal length also changes. If the radius of curvature is small, little, then the focal length is also very little. If the radius of curvature is more, the focal length increases. In this way, focal length is dependent on the radius of curvature. We can give a simple rule. Usually, focal length will be half of the center of curvature, half of the center of curvature. F is equal to R by 2. Usually, we use that formula for mirrors. Even for the curved surfaces, we can use here, but it is not exactly correct, because the lens is bulged. We have to consider the optic center. Usually, we call this point as the optic center. From the optic center, if you would able to measure the distance, then we can use that formula. In this way, we can know the focal lengths of the objects. So, you try to find out the focal length of the magnifier which you might have, if you have, and what is the focal length of that. And you collect different type of magnifiers and observe a type of which lens gives the clear image. These days, all the mobile phones are having 4, 3, 2, so many lenses. How do they act to give the correct image? Try to study about that and know in which case we can get the clear image, and what type of image is formed, whether it is an inverted image or a erect image. Try to know and enrich your knowledge. Thank you.